Let's take a moment to talk about histograms. In particular, let's discuss the intuition behind them and how we can interpret them. Histograms describe the data's observed range and frequency. If we think back to the examples of variables that we had in the earlier video, we can gain an overview of the distributions for those variables using histograms. On the left, we have the number of heads that came up over 2 coin flips for 10 separate trials. That means if we flipped a coin twice, counted the number of heads, and repeated that process 10 separate times, we have 2 coin flips for 10 separate trials. For this histogram, we can see that for 2 trials, no heads came up at all. That is, the height of the bar at 0 is 2. For 5 of the trials, 1 head came up, that is the bar in the middle. And finally, 2 heads came up for 3 of the trials, which is the bar on the right. Turning our attention to the plot on the right, we see the distribution of the numbers of minutes late that each of the 75 employees were on a given day. We can see that most employees arrive right around the start of their shift, the bars from -1 to 0, and the bar from 0 to 1, representing employees that were respectively 1 minute early to on time, and between on time and on time plus 1 minute, respectively. These bars are the highest, which means that most people were approximately on time. As we get further from the beginning of the shift time, we see that fewer and fewer employees arrive within each time frame. On the left, we can see that only 1 employee arrived more than 4 minutes early, as the bar height at less than -4 is 1 person. On the right, we can see that only 1 employee arrived more than 4 minutes late for the shift, as the bar height at greater than 4 is also 1. As we can see here, histograms can provide a great deal of information about the range and the frequency of the values that the data take. One of the important considerations when creating a histogram is selecting the appropriate bin size. There are a few rules of thumb that we can use here. First, bins should always be of equal size, and you'll notice that in the last histogram we move in 1 minute increments. Second, we should include all of the data in the bins. Outliers can be lumped into the first and last bins. We also see this in the histogram, where employees that are more than 4 minutes early for their shift or more than 4 minutes late are lumped into the leftmost and rightmost bins respectively. Finally, bin size should be small enough to convey the patterns in the data, but large enough to avoid reflecting only noise. This last rule may seem a bit ambiguous, and indeed it is, so let's take a deeper look at this in the next slide. Here we are going to try multiple bin size to find the right one. If we look at the employee tardiness plot, where instead of counting by minute, we count by a much smaller increment, we can see that most of the pattern in the data is noise. And that's because very few observations fall into any given bin. As we start to make the bins slightly larger, we start to see some patterns in the data. Here we see that most employees arrive roughly on time. However, we still don't see that clearly that clear bell curve pattern that we saw previously. This histogram has the pattern that we saw previously. And finally, if we make the bins significantly larger than 1 minute interval, we see that almost all of the employees fall into one of 2 different bins, and this is not particularly helpful.